So first thing I want you to write down, please, for your midterm review is rational versus irrational. You need to know the difference between these two. I called um, irrational numbers ugly numbers, but what it is an irrational number you could never get into a fraction. So basically, if you try to math one fraction it, it will not work. If you try to math one fraction a number and it doesn't go into a fraction, it's going to be irrational, okay? The most famous irrational number is pi. So if I was to type in pi on my calculator, okay, so that number there, this is pi. The decimals for irrational, they never terminate and they never repeat. And if I try to math one fraction this, it will not go into a fraction. This number will go on forever and there'll be no repeats, okay? The square root of 2, that's an irrational number because the square root of 2, again, if you typed that in and you tried to math one fraction that number, it will not happen. The rational numbers are all fractions. If you can get a fraction, it's going to be rational. Can somebody tell me, why is the square root of 25 rational if the answer is 5 and it's not a fraction? Yes, you put it over 1. That's really 5 over 1. Okay. If I give you a number, so let's see if you remember how to type this into your calculator. So let's say I give you this. What this means, it is 6 times the third root of 8. If I ask you if that's rational or irrational, you have to calculate that. You've got to stick that in your calculator. So how you would do that is you would hit 6 times your roots are under your math button, number 4. Third root of 8, it gives you 12, right? That answer is 12. So that would go in this column, 6 times the third root of 8. Let's say I give you the fourth root of 110. Let's see if that's rational or irrational. So the fourth root of 110 is that number there. It will not go into a decimal. This is going to be an irrational number. Or sorry, it will not go into a fraction. Okay, after we did numbers, right, and we talked about the number system, so those are the two systems, just what we talked about that you need to know. We then looked at radicals and simplifying radicals. So let's write simplify radicals. For example, if I say simplify the square root of 360, how we did that is we rewrote it as a product of the prime factors. So remember the prime factors were 2, 3, 5, 7, 11. You take whatever number I give you and you start dividing it by its lowest prime. The lowest prime is going to be 2. So you'd say, okay, 360, and usually these are big numbers, so you put them on your calculator, divided by 2 is 180. 180 divided by 2 is 90. 90 divided by 2 is 45. 45 is not divisible by 2. A lot of you want to jump up to 5, and I mean, you technically could, but I always check the next prime number, which would be 3. And what number would you get? You would get 15. 15 is divisible by 3, and you would get 5. The square root of 360 is equal to, you're going to have all those numbers circled. The one number that students forget sometimes is that last number there, and you get everything wrong if you forget it. Even if you broke this down perfectly, because it'd be a multiple choice or numerical response question. And if you forget that, you would not get the answer. So I have 3 2s, 2 3s, and a 5. What is my invisible index? It is a 2. That 2 tells you to circle groups of 2. For every group of 2 that you circle, you cross it out, and how many come out? 1. 3 times, or this one, a group of 3s, cross it out, and 1 3 comes out. What is remaining is your radicand, and it has to stay there. So I've got a 2 and a 5, so what's remaining is 10. And then you would evaluate this. 2 times 3 is 6 root 10. You are able to check your answer for a question like this. If you wanted to know if you were right before you submit your test, or when you finish this question, you type in the square root of 360 on your calculator. Then you type in your answer, which was 6 root 10. And you get that. If it's identical, you've simplified. Yes. No, it will not. This is going to be an irrational number. Okay? And the reason is, it's not a perfect square, perfect cube. If it was, all of those numbers would come out, and then that would be a fraction. If you have something left under here, it's always going to be like prime numbers that were left, so it's going to be irrational. Yeah. Okay, do you remember how to go backwards? So going backwards would be the following. 3 times the root of 5. If I say express, this is a mixed radical, and what the question would be is express this as an entire radical. Entire radical means you need to get that 3 somehow underneath that radical sign. You say, like, how did they get that 3 out there? Well, there's an invisible 2 here. This is what you would put underneath your radical sign. And then a 5 is already there. What you would type into your calculator, you would not enter the radical sign because I don't need that. I just want to know what the number is under here. What's the radicand? So it's 3 to the power of 2 times 5. If you did that on your calculator, you would get 45. Okay, try these two. So 4 times the third root of 6. How did they get that 4 outside, and how do you do the reverse and get it back underneath the radical sign? This is what goes under. The 6 is already there, so it remains. I'm missing something. Do you know what I'm missing? If this is a third root, this has to stay a third root. Okay? And then the answer would be the third root Ainsley, you're getting 384? 384. And again, how could you check this? You would type this in, that's the mixed radical. You would type this in, that's the entire radical, and you get the same answer. You guys, I could give you this question, and I could say express this as a mixed radical. You'd start dividing it by 2, then by 3, right? And then you'd circle, what would you circle? Groups of what? 3. Yeah. That is numbers, okay? In your review package, there's, I think, 13 questions. Sorry, that's numbers. We got to go to exponents. There's 13 questions. It'll give you a ton of practice on reducing, going backwards, using your calculator, so you want to do that. Let's review exponents now. Yes, this is at home. I would do everyone. Do you remember what to do here? We cannot have negative exponents. If it's a negative exponent, you're going to reciprocate it. So if you write it down there, you would have 1 over a squared. So for example, if I gave you negative 3, a negative 4, b 6, c negative 2, no, it's going to look identical to your unit exams. Okay, how would you do this? What are you going to move from the numerator into the denominator? Ainsley? Yes. That negative 4 belongs to the a, not the negative 3. And then you have to move this one. That negative 2 belongs to the c. So your answer would be negative 3, b to the 6, over a to the now positive 4, c to the 2. Okay, what if you had this? First thing I would do is I would say, how could I rewrite that fraction so that I could go from a negative 2 to a positive 2? What do you have to do in order to go from a negative 2 to a positive 2? You flip this guy, you reciprocate what's in here, but you change nothing. You just reciprocate exactly as it is. So that goes into the numerator. This would go into the denominator. Okay. Then from here, you could bring your a up if you want. Right? There's 2 ways you could solve it from here. Or you could start distributing your 2. When it's power to a power, what's the operation? Multiply. The answer, okay, then you get b to the 6 over a to the negative 4, and you must get rid of that negative 4. That goes back up, and that would be your answer. Okay, what about write this down? Negative 2, a3b to the power of 2. it looks easy, right? Because that 2 has to go here, here, and on the 2. But is your leading coefficient going to be -4 or +4? Whatever number is in the bracket, which is a -2, the exponent would be on the outside of the bracket. It would be a +4. A lot of people for this, here's what they'd enter on their calculator. They would just say -2, and then they'd enter it, raise it to the power of 2, and they would get -4, and you would be wrong. Then it is a to the 6, b to the 2. Okay, what would you do for this? Um, 6, x to the 4, y to the -3, all over 14, xy2. Reduce your fraction. So you could do it one of two ways. You could type in on your calculator 6 divided by 14 and math 1 fraction it. And what you will get is 3/7. Or you could divide each of those numbers by 2 and you get 3/7. Then you apply quotient law. There's a 1 here. So quotient law is subtraction. 4 minus 1 is 3. The y would be -3 minus 2 would be -5. Because you write it, like when you apply quotient law, you write everything up top and then you move at the end. And then you would say, okay, this has got to go. So your answer would be 3x to the 3 over 7y to the 5. I suggest looking at like quizzes that we've done as practice. Okay. What would this be? You cannot have negative exponents. You cannot have fractional exponents. If it's negative, we reciprocate. If it's fractional, you turn it into a radical and you use flower power. So you put the base underneath your radical sign, and then you figure out with this 5/3 which is the power and which is the root. Juan, what would the root be? 3. Yep, because if that's the ground one, roots grow underground. So that would be 3, and this would be 5. Okay. What about this? -5/2. What do you think you do first? Do you turn it into a radical with a negative, or do you turn it from -5/2 to +5/2? You get rid of that negative first. It would be 1 over a. Do not flip that fraction. It's still 5/2. Okay? And then from there, turn that into a radical. A goes underneath your radical sign. I do not need to put the invisible root of 2, and it would be to the power of 5. Do you know how to get out of a radical? So if I said I said that, how would you get out of the radical? You would do your reverse flower power. Take that out of the radical, find your ground, roots grow below ground, and powers are above ground. What would you do if you saw this? So think about bases are the same. You got to apply exponent law, right? If I gave you a to the 2, let's say, times a to the 6, do you add 2 plus 6 or do you multiply 2 plus 6? You add. So that would be a to the 8. So you apply the same thing for fractions. Who cares if they're fractions, right? You need to add 1/2 plus 3/2. If you're not good at adding fractions, you could punch it in your calculator, make sure each fraction's in a bracket. And that would be 4/2, which would be x to the what? 2. That is pretty much numbers. And you want to, again, do all that practice so that you could do all of this.